So we're in our course, Science and the Scientific Revolution, the history of innovations and the history of science, and all of that is combined in this course. The very beginning of the scientific revolution started with Nicholas Copernicus. That's where we would put it. Back in 1450, about 1450, we got the printing press, which was a tool that was getting the momentum going. That was in 1450. Around 1450 from Johannes Gutenberg in Germany, in Mainz, Germany. Here's what's interesting though. Around this time, we have Nicholas Copernicus born, 1473 to 1543. And when Copernicus got to study science and so on, he realized that the Earth was not the center of the solar system, but the sun was the center of the solar system. And so he wrote a book. His book was titled On the Revolutions of the Celestial Spheres. On the Revolutions of the Celestial Spheres. By the way, there's not original, but there's copies of his book online that you can read if you want for fun. If you love astronomy, you should read his book. And so if you studied Aristotle, you should understand the title. Aristotle thought that the planets were embedded in spheres that revolved around the Earth. While Copernicus agreed with Aristotle about the spheres, he made a significant change to Aristotle's view. He put the sun at the center of the universe, when Aristotle had put the Earth at the center. Now, Aristotle was good at logic, okay? He was good at other things, but maybe not so much at astronomy at the time. But then you also have to have mercy on Aristotle. He didn't have sophisticated telescopes. Galileo gave us a telescope, or his work came later, but Aristotle is living around 300 BC. We should be happy he knew that we were, there was spheres. So there's no flat Earth. It is a sphere. I'm sorry if this causes trouble, but I just wanted to explain that the spheres was the basis that he used there. And as far as explanations about the sphere versus the flat Earth, we can have that conversation sometime too. But basically, the heliocentric view was not new, right? There was another man, Aristarchus, who might remember, he suggested a sun-centered system around 230 BC. However, the Earth-centered system, called the geocentric system, was considered the correct view by almost all natural philosophers in the 16th century. Scientists used to be called natural philosophers, by the way. So back in the day, a lot of those scientists had better philosophical skills than the scientists today. That's why in my program, I emphasize that we need to raise the next generation of scientists, mathematicians, and thinkers who also know the history and philosophy of science, logic, and theology. We need our students to have a solid, well-rounded education. Okay, as a result, so Copernicus suggested, what he suggested was controversial. That happens sometimes in science. You come up with an idea, it's controversial, there's some pushback, and sometimes people budge and deny their own scientific discoveries, or they can choose to stand firm, and we need to learn to stand firm. And so he hesitated publishing it. This took a while. So that's where some of the writings, we start seeing this in the 1500s, right? But at this time, we also get Martin Luther with the Reformation happening, and literacy is rising. So we get we have the printing press, we have the Reformation happening around 1517. Well, some of it was already happening, but there's some momentum happening now in Germany also. And then we have this Polish scientist or astronomer doing his work as well. So why did Copernicus suggest that the sun is at the center of the universe instead of the earth? One key reason was that he believed God created the universe, and therefore he thought that the universe should be very orderly. In his book, he wrote, "The machinery of the world has been built for us by the best and most orderly workman of all." However, the geocentric view of the universe was very messy. If you study the work of the ancient natural philosopher Ptolemy, around 90 AD, you know that the geocentric view of the universe had to have several epicycles added to it in order to make it consistent with what most observations that the astronomers had made. Okay, so there's more to his reasoning behind this, and there's examples that are given in this first chapter. I'll end with this. Copernicus' arrangement could explain some observations that had always puzzled astronomers who believed in the geocentric system. For example, the planets that astronomers knew about during the 16th century were Mercury, Venus, Mars, Jupiter, and Saturn. They noticed that Mars, Mercury, and Venus never appeared in the eastern sky after sunset. When they appeared in the sky after sunset, it was always in the west. That was hard to explain in the geocentric system. So, Copernicus gave us a solid explanation and gave us the beginning of understanding the heliocentric system. The scientific revolution has begun. This is around 1550s It's a rough range here, but let's go from 1500 to 1600. Can we just agree that there's a lot of stuff that we can begin to attribute to this rise of a revolution? Galileo carried on this. Galileo got in trouble, but it worked out in the long run. He was under house arrest for part of it, but the belief in the sun as the center of the solar system was enough to cause people to actually get in trouble back then in some circles. No pun intended. And then after Galileo died in 1642, and Isaac Newton was born in 1642. So Newton kind of came right at the time when Galileo had already given us a lot of stuff, and then Newton comes and he takes it to the next level. Isaac Newton, by the way, gave us the mathematical language that astronomy needed badly, the explanation with equations to explain some of these planets. Newton wasn't perfect. Einstein came later and corrected some or gave a different paradigm. See, the paradigm of a geocentric model and a paradigm of a heliocentric model will affect further study. So it's in the philosophy of science, there's this idea of different paradigms and different models for describing what science is and what science isn't. We'll talk about that more in our course, but we've laid the groundwork for the heliocentric view of the solar system. For more in-depth studies on that, I'll make a different video. Just email amosthemathguy@gmail.com, amosthemathguy@gmail.com if you want to continue the series and in-depth study on the heliocentric view of the solar system. Order is very important. Let's end with a life lesson. I was just thinking about this today. When you leave a bottle of water, right, bottled water somewhere, right? If you leave a bottle of water and somebody hits the bottle of water, it spills on the floor and now somebody else can fall. Notice that because of disorder, it has caused trouble in many levels. So order is important. And so we need to make our beds, right? As Jordan Peterson would say, actually it was the Admiral that said that, the UT commencement, and he wrote the book, Admiral McRaven. But we need to make our bed, young people. We need to do our chores. We need to arrange things and do our best to have order. And it reduces chaos, which is the opposite, but it reduces the effects of chaos. I look forward to studying more of the scientific revolution. Some of this recording will actually come out of Trinity College in Cambridge. I'll be recording that August 1st to the 17th week. I'll be in Cambridge, and I look forward to maybe meeting some of you and discussing the history and philosophy of science and the metaphysical implications of some of the discoveries in chemistry, physics, and mathematics. Take care and have a blessed day.